hope you're having a great day. Today we're going to talk about positional number systems. But before we go and get into the details of positional number systems, let's take a brief look about digital data and how that is represented inside our computer memory. So basically, data in the computer is representing using zeros and ones, right? That's kind of common knowledge that inside our computer everything is zeros and ones. More specifically, the hardware units that are basically inside the computer memory doesn't really have like a circly a zero and a line for one. It is using hardware that basically can be in one of two states. We as people interpret these two states as zero as one state and one for the other state. If it is an electrical based unit, no flow of electricity would be considered zero, and if there is a flow for electricity, that would be considered one. If it is a magnetic kind of unit, then magnetic field goes in one direction would be considered zero, and a magnetic field in another direction would be considered one. So depending on the physical structure of these atomic units, we are interpreting these two states differently, but anyway, we think of them as zeros and ones. Logically, we like to think of the memory as just a very long sequence of zeros and ones, grouped into 8 each one. Basically, we call each one of them a byte. Using zeros and ones, we can represent numbers by the binary number system. We'll talk about it in much more detail later on. But as you know, in our computer, we like to represent not a lot of kinds of data. For example, not only numbers. So numbers can, assuming we understand binary number systems, it seems that binary can be represented using the zeros and ones in a very straightforward way, just by their binary representation. But our computer memory contains data that is from other kinds. For example, it can have text. If you write emails or whatever, the data, the textual data is also stored in the memory with zeros and ones. That's the only alphabet we have in the computer's memory. So we should figure out how to represent text using zeros and ones. Your memory can contain images. How do we represent images using zeros and ones? It can contain videos, it can contain audio, and a lot of other types of the data. Let's take a look at, for example, text. How can a text be represented using zeros and ones? So, since we want to represent a textual information, and we want to represent it with zeros and ones, a very common strategy to use here is to map each symbol, each textual symbol, into a number that then can be represented binary. We typically use an ASCII table. This is an example of such a mapping. Later on, we'll get into the details in some one of the future lessons. We'll get into the details exactly. But just as the main idea, each letter or character, as you see, is mapped to a number. So, for example, if we want to code the text "Hello World," then we look for each letter and map it to its corresponding value. So, for example, H is, or uppercase H, is 72. So instead of writing H, we just write 72 for that H. Lowercase e is 101. So we would have 72 followed by 101. L is 108, so then we would have 208, and so on. O would be 111, space is 32, uppercase W is 87, and so on. So basically, a sequence of characters would be mapped to a sequence of numbers, which in turn can be represented using the binary number system. So each character would be mapped to a number. You can see that when we are representing text, we are doing it in some sort of a two-step representation. First step is coding it as numbers, and then numbers we already know how to represent using zeros and ones.